This video is the next in a series of videos that talks about how to compose units. In the previous video, we looked at employing platform models on a unit, and in this video, we're going to look at employing cognition models. Cognition models are, hands down, the most important type of model that can be attached to a unit. They are extremely powerful. They're extremely capable because they're able to model human behavior, but they have, in addition to that, they have a lot of other attributes that make them very, very important in flames. In a real battle, battles are fought by humans. Humans don't directly interact with each other. At least the human cognition does not directly interact. There's no way for two brains to interact. We're not Star Trek with Vulcan capability. Human brains are always controlling some type of device. So if you consider the human body as a type of platform, which is how it would be treated in a flame scenario, the human body would be the platform, and the brain of the human would be the thing that's controlling the motion of that human body. So that would be the cognition model. If you're talking about a fixed-wing airplane or a ground vehicle or a ship or a tank, it would be the humans that are driving those vehicles that would be modeled by the cognition models. And platform models can't move around in a flame scenario without a cognition model. Now, you could write a cognition model, a platform model in flames that could move without a cognition model. In fact, you could write a unit that could move without a platform model. You could make a sensor model move the unit. It would be difficult to get the unit to draw without a platform model, but you could violate all of the purposes of all the different models in flames and do something any way you wanted to. But what we're teaching you is the built-in support that flames has for performing different types of modeling, and we have classes that are designed specifically to support that type of modeling. And it's our recommendation that you use our classes appropriately for the type of modeling that you want to be able to perform. And anything that happens inside the head of a human is generally modeled by a cognition model. And so since every player in the scenario has a human associated with it, since everything that happens in the world is controlled by humans, the cognition models are extremely important. And you'll almost always have a cognition model attached to a unit. And like other types of units, other types of models except for platform models, you can have as many types of cognition models, as many instances of cognition models attached to a unit as is appropriate. And it's very common for flames units to have multiple cognition models attached to them, with each cognition model adding additional human behavior capability to the unit. The one type of unit that is very common that does not have a cognition model attached to it would be a munition. So when a unit shoots a munition, say shoots a missile at another unit, the unit will have a type of platform, a subclass of platforms, of a platform called a munition model, which we'll talk about in another video. And that'll oftentimes be the only type of model that's attached. So when we launch a missile, a unit gets created dynamically, a new munition object gets cloned and attached to that particular unit. And then that munition model, which again is a subclass of platform, that munition model then is given a command directly to fly toward a particular target, and that's done internally. And there is no human on the missile itself, because in the real world there is no human that's actually flying along with that missile. The humans controlling that missile from the launching platform usually. So that would be an example of a type of unit that would not have a cognition model, and that's a very common type of unit. But the units that you create in Forge, that you're going to want to be able to command and give them instructions to follow and give them complex behaviors, they'll always have a cognition model. And as I mentioned just a second ago, we recommend that you use the classes that we've designed, and you use those appropriately. when you're building models that represent the behavior of a unit. And one of the reasons we recommend that, one of the biggest reasons, is that we've chosen our primary classes, our primary modeling classes, to mirror the organization of real world systems. So in the real world, a sensor does not have cognitive capability. A sensor is a physical device. It's an inanimate object. And it's a real human with cognitive capability that's controlling that sensor and looking at the information that's coming from the sensor. So in Flames, we have been very careful to create modeling classes that represent things, the types of things that exist in the real world, and the interfaces between those classes also represent the way that different types of things in the real world interact with each other. It's been our experience that if you want to accurately model something in software, in a simulation, the classes that you pick need to be representative of the way that things are designed in the real world, or where things exist in the real world. In fact, I'll digress a little bit more. Object-oriented programming is a really great approach for developing software. Flames is religiously object-oriented. We're fanatical about that approach. We think it's the best way to write software in most cases. And Flames is religiously object-oriented. But object-oriented programming itself does not guarantee that you're going to have a well-designed system. Just like a given programming language is not going to guarantee that you have a well-designed system. There are people who think that you're going to have a better simulation because it's written in C++ versus in C, because C is not a true object-oriented language, or better than Fortran, or there was this foolish notion many years ago that we were going to have better software in the United States Department of Defense because we're all going to use this new programming language called Ada. And if we make everything in Ada, everything's just going to get better. And it's true that some languages have constructs in them that are very helpful. C++ has some really nice constructs in it that C doesn't have, that, in my opinion, makes C++ a better language for developing software. But there's an old adage that says real programmers can write Fortran in any language. And that's really true. It's not the language itself that makes a software system well designed. It's the human designers that are using that language properly. And that boils down oftentimes to the classes that you pick. If you have a well-designed class hierarchy that knows when the proper distinction between classes, you've factored all your components of your systems into individual classes, you know the relationships and interfaces between those classes, you know when to use inheritance, and you've established the appropriate class hierarchy. If you get all that right, and it's very hard, it's very difficult to get that right. If you get that right, you can have a very well-designed system that yields the benefits of object-oriented programming, the benefits of encapsulation and of polymorphism, and other benefits of object-oriented programming. But if you choose and design the wrong class hierarchy, you don't break things up right, you don't factor things correctly, you don't use inheritance in the right places, you're not going to have a well-designed system, and you can have a system that is just as difficult to maintain and enhance and design and develop than it would be if it was just the worst Fortran spaghetti code. And one of the ways that you can be sure, or you can help be sure, that you design the right class hierarchy is that you mirror your class hierarchy and you organize it based on the way things are organized in the real world. That's why we have platforms, because in the real world there's platforms. That's why we have sensors, because sensors are separate from platforms in the real world generally. And so we have a separate class for sensor. And we have made sure that our class hierarchy mirrors the things in the real world. And the classes that model things in the real world are not the same classes that model things that don't exist in the real world. So our user interface is not part of our platform class, the user interface software. Platform classes have a user interface, but platform models aren't designed to model user interfaces. We have other classes that model user interface and other software that does that. So we don't embed our fundamental user interface code inside of a platform. We have memory managers that are separate objects from Flames, and dozens and dozens of different classes and services that do infrastructure and management type things in the simulation. And they are separate from the classes that model the things that exist in the real world. Again, in order to help us get a well-designed class hierarchy. That's one of, in fact, I'd argue it's one of the top reasons why you should use Flames to develop a simulation. Because Turnian has gone through the very difficult task of designing a class hierarchy that is well suited for modeling military and transportation related type situations in the real world. It took us a long time to get that class hierarchy right, and we have it right, and it is very well suited for this type of problem. It is not well suited for modeling an accounting system. You wouldn't use Flames for that because our class hierarchy is not designed to model accounting. But it is designed to model transportation and aerospace and defense type scenarios, scenarios where there are independent objects, real world objects that act and interact in time and space. We have a well-designed class hierarchy for that. So the hardest part of the simulation design, hands down the hardest part, we've already solved. And you get to take advantage of that when you are writing your classes for Flames. So that's a little bit of a sideline. That's a little bit of the theory behind Flames, and that's why we have these cognition models that are totally separate from all the other types of models, because the human brain is totally separate from everything else that exists in a real world scenario. So let's put a cognition model on this guy. Stop with the theory and move on to something practical. So I'm going to say employ. I'm going to use the same statement. I'm going to employ cognition. Then I'm going to do the same thing. I'm going to browse for one of my existing cognition model meta objects. And so I'm going to put on a driver. So I've got three. Well, I'll go back to that in a second. Let me just put this on here. So I've got a driver. And I hit accept, and because I did it syntactically correct, I don't get any errors. I go over to my composition, and now you see there's my two models, my ground vehicle and my cognition model. I'm going to double click now on this and look at the meta object that I cloned when I employed this cognition model. And so I'm over in the cognition model window now, and I could get to that window like any other meta object window by going off of the parameters window. So here's cognition model, it's the same window. And I've got three different cognition model classes, actually four, that I have as part of the tutorial models, the tutorial components. So I've got a driver, and that is, as the name implies, that's what drives a ground vehicle model. I've got additional behavior that I can attach to a unit if this particular unit is going to shoot at things, going to detect targets and shoot at things. Then I've got other kind of behavior that if I'm not the shooter, but I'm the commander of other units that are the shooters, I've got some additional cognitive behavior that implemented in that class. So I've implemented these separately so I can mix and match them to compose different kinds of units. This particular cognition model is what we use in some of the developer tutorials just to teach cognition model development in general. And so it's an extremely simple cognition model that really doesn't do anything. It's just a shell of a cognition model, but we use it to teach how to build cognition models. So I'm not going to use that in this scenario. But before this set of videos is finished, this course on composing units, we're going to be looking at each one of these different cognition models. These cognition models don't have any input parameters. You certainly can, but these are so simple that they don't. And so none of these cognition models will have any input parameters. So there's nothing to specify here. And because of that, it doesn't really make sense to create multiple instances of this shooter model because there wouldn't be anything different about the instances. So it's not uncommon that we name the meta object just the same as the name of the class. We don't do that for other types of models. So both of these meta objects are members of the same class, but we don't name the meta object using the class because these guys have different input parameters. They happen to have the same max speed, but they have different teams and different icons, and so each meta object is unique because it has unique parameters. So we will name these things that are descriptive of what this vehicle is. But cognition models, we oftentimes don't do that. We just name it the same as the name of the class. I hope that's not confusing for you. Let's go back over to the unit now. So now we have two different models attached to this unit. And I'm going to take this cognition model off for just a second. So I'm going to highlight this and cut it and hit accept. So go back to composition. I have just one model. I'm going to go to my commands tab. And I want to show you that there are no commands. All of these buttons are ghosted. I can't add commands or remove. I don't get a way to specify any inputs because there are no commands. Commands come from cognition models, exclusively come from cognition models. That's one of the reasons why cognition models are so important. So I'm going to show you now. If I go back to the script, I'm going to paste that statement back in and hit accept. You can see in my composition, I now have a cognition model. And now I go to the commands tab, and you can see now that I have a couple of commands. There's actually more commands that are available for this cognition model, but these are the commands that can be specified as a part of the definition of the unit. So we're going to talk about that in the next video, actually. In fact, I'm just going to, right now, though, I'm going to go over to this cognition model window. One of the things you can do in the cognition model is you can see the methods that are implemented for that cognition model. So here's the driver cognition model. I can go to the methods tab, and here's all the different methods that are implemented for that model. You can't edit them or change them. It's just for information purposes for somebody who's building a scenario. And it shows you which commands are used to invoke those methods. So these are the commands that are available. Some of those show up on the user interface. Some of these are internal commands that do not show up on the user interface. And we'll talk more about those when we talk about how to develop cognition models. But you'll notice, for example, that the move information command is defined here. And if I go over to the unit and I click add command, I don't see move information command. So we're going to talk about that in the next video, about why we don't see that command. But for now, I'm going to add one of these commands here. I'm going to add the locate command. So if you click on these different commands, as you already know, you get a text description of what the commands do. And again, these are commands that are defined by the cognition model. And as you've been told before, these commands are not defined by Flames, and now you understand why. They come from the cognition model. So it's the developer of the cognition model that chose the name of these commands. It's the developer of the cognition model that specifies what that command's going to do, which method it's going to invoke. The cognition model developer wrote that method, so the cognition model developer chose what's going to happen when that command is initiated for a unit. And the cognition model developer actually typed in this description. So if the developer did a good job of explaining it, it makes it easy for you to understand what this command does. So this one is immediately move to the specified location on the ground. So this is intended to specify the initial location of a unit. So I can say add or add and close. If I double click, it's the same as selecting add and close. So I'm going to do add and close. So there I have this command. And when I add a command, it doesn't immediately accept the addition of that command until I have a chance to edit the inputs, just in case there are some required values that are required here. This particular location it's someplace in the middle of the Earth. It's near the equator. I'm going to double click on this value. You already know how to do that. I'm going to specify a location there. And then I'm going to, then when I did that, that did cause the value to be updated. So there it is, it updated it, and boom, I now have my unit. It's the cognition on my 2D map. The cognition model is, I gave a command to the human. I said, human, I want you to locate the platform. So put the whole unit at a particular location, and this is the location where I want you to be located, where I want you to position yourself. So I did that, and suddenly now my unit shows up. So the platform was always there. The platform always had the icon, but we couldn't locate it because we didn't have a human. But now that we have a human, we now have commands, and these commands ultimately give commands to the platform. And so when I specify the locate command, I it locates the platform. That's what it does. It locates the platform. And as you already know, I can edit this guy, and I can move this guy around by the map. And you already know about command editing, so we're not going to go into that anymore here. So now I've got something that's beginning to look like a real unit. I've got two models attached to it, and most units will have one platform and at least one cognition model. And now that I've got a cognition model, now I can edit the unit and tell it to do things from the command editor, which is the appropriate way to do things. By the way, as you may not know this yet, may not have noticed this, but when I added that command, it edited my script, and it put in this initiate statement. So initiate statements are not statements that you'll want to try to edit by hand. They have a pretty complicated syntax. It's a lot of typing. We don't have script editing capability that helps do all this. You don't know what the commands are. You don't know what the inputs are. So you don't edit initiate statements by hand. But initiate statements are the statements that you will see most often in script, and they are always edited through this graphical user interface here that has a lot more information on it, a lot more tools for editing. So I'm going to save my overall scenario, which will save the unit data set because I've modified content there. So I now have one unit in my scenario. Very simple, and all I've done right now is I've located it. So we're going to make this unit more complicated, but before we do that, we're going to talk about command execution order, the order that these commands are executed and how it relates to the script. And we're going to do that in the next video. So that's all I want to talk about in this video. Thank you for watching, and thank you for using Flames.